Determining sample size. Up to now, we always thought that we know the sample size somehow. When we wanted to take a sample and make an estimation of population parameters, for example, population average, the population proportion, etc., or to build a confidence interval, we assume that we know n, the size of the sample. But what should be the size of the sample? How we would know to decide n? What should be the value n, the size of the sample? Should it be 50, 30, 25, 200, 2000? Well, that's a very important question that we want to talk about it now. So we're going to talk about determining the size of the sample based on what we want to estimate, mainly the parameters of the population. So we're going to talk about determining the size of the sample for when we want to estimate the average of the population or when we want to estimate the population proportion, both for point estimate and for confidence interval. To be able to determine the size of a sample, we need to talk about sampling error. If you remember what sampling error is, the required sample size can be found to reach a desired margin of error with a specified level of confidence. So for example, when someone, for example, your boss, want to ask you to build a confidence interval for a parameter of the population, suppose for the average of the population, then he would give you his expectation, his or her expectation. For example, build a 95% confidence interval with a margin of error of whatever. So he or she would give you the margin of error. And this is the key point to starting figuring out how large of a sample you have to take. The margin of error is also called sampling error. Sampling error is the amount of imprecision in the estimation of the population parameter. The amount added to and subtracted from the point estimate when you want to build the confidence interval, if you remember. So if you remember, for example, for building a confidence interval for the average, we used x bar as the point estimate, plus minus z of alpha over 2, the critical value, multiplied by sigma over a square root of n. So this together is called margin of error or sampling error. So when you want to build this confidence interval, for example, your boss would ask you, okay, build a 99% confidence interval with a margin of error of E, for example. E is a value. Then E is equal to this value. And this is the key to find this sample size, which is n here. Determining sample size when we want to estimate average. So when we want to estimate the average, we know that this is the confidence interval. The point estimate plus minus the margin of error. Based on this and knowing the margin of error and the confidence level, we can find the size of the sample. So the sampling error or the margin of error should be less than E. E is the given margin of error that your boss, for example, is asked you to do that. So he would ask you, okay, build a 99% confidence interval with a margin of error less than E. So E is a value. This means that your margin of error must be less than E. So from now here, you can actually solve for n. And you get this value. N should be greater than this value. Z of alpha over 2, the critical value squared, sigma squared over E squared. So n should be either equal to this value at least or greater than this value. So what this inequality gives you is a lower limit. At least. It means that, okay, n should be, for example, at least 100. That means that if you take 100 or more, you're gonna acquire that level of margin of error that you are asked to do. Let's see an example for identifying or determining sample size when we want to build a confidence interval for the average. If sigma, the standard deviation of the population, is given as 45, what sample size is needed to estimate the mean, the average, within plus minus 5 with 90% confidence? So this plus minus here is actually the margin of error or the sampling error. So you have the margin of error, you have the confidence level, and you have the standard deviation. You can plug in the formula and find the least amount of the sample size that you have to get this to the level. So we're going to plug in this formula. N should be greater than the critical value of 5% because 1 minus alpha is 90%. This means that alpha is 10%. So z of 10% divided by 2 is z of 5%. So we find z of 5% squared, sigma 2 squared, and E squared. And that would be end up having 219.90. Because we are looking for a value of n is the sample size cannot be, it should be a whole number. It cannot be decimal. And because n should be greater than that value, so we always have to round up the next integer value. So our value would be the next integer value, which is 220. So always round up for n. So the size of the sample should be at least 220 to give you the condition that's required. Determining sample size when we want to estimate proportion. So for the proportion, we know the formula and we know the margin of error. So when someone asks you to build a confidence interval to estimate proportion, population proportion, he or she would ask you, for example, to build a 1 minus alpha % confidence interval. That means that it gives you the confidence level, for example, a 95% confidence level, which is alpha here is 5%. Also, he would ask you to the margin of error. Said the margin of error should be less than E. E is a value, a number. So you have these two values. You have alpha and E. And based on this, and also knowing the margin of error, you can build from here and work backward to find and solve for n, the size of the sample. Let's see how this works. So this is the margin of error in our formula for confidence interval formula for proportion. It should be less than E. E is a given value, the margin of error. We know this. So now from here, we can actually solve for n. And this is what we get. N should be greater than or equal to critical value z of alpha over 2 squared multiplied by p multiplied by 1 minus p over E squared, which is the margin of error. But if you note here, we have p in the formula. And we want to estimate p. That means that we don't know p. So what should we do? We will figure out what to do. To determine the required sample size for the proportion, you must know, first, the desired level of confidence, which is 1 minus alpha. From there, you can determine the critical value z of alpha over 2. And also, you need to know the acceptable sampling or margin of error E. And the true proportion of events of interest P, based on the formula that we got previously. But how we can know P? We don't know P. We want to estimate P. When you don't know P, you can actually estimate it by try and error. So P can be estimated with a pilot sample if necessary, or conservatively, you can actually use P equal to 50%, 0.5, as an estimation of P. Why? Why this would work? Because in the formula that we found for n, previously it was n has to be greater than or equal to z of alpha over 2 squared multiplied by the margin of error multiplied by p multiplied by 1 minus p over e squared. This formula, n should be greater than this value. So we can actually act conservatively and find n that bigger than anything else based on value of p. It means that if you actually solve this problem for p equal to 0.5, that would give you the highest lower end of n possible. It means the most conservative n possible. So that's why 0.5 would work here, or 0.50% or 50%. So you either can go ahead and do a pilot sample. That means that, okay, for example, go with pick a sample of size 50, 30, whatever, and then estimate p hat, and then use p hat instead of p in the formula. Or you can go ahead and be conservative and take a value of 0.5, so it would give you an n, the largest n possible, the minimum largest n possible, and that n would actually work. Let's see an example. How large a sample should be to estimate the true proportion of defective items in a large population within plus minus 3% with 95% confidence? So here it gives you the margin of error, and also it gives you the confidence level. You can find it based on 1 minus alpha that it's given here. So let's go ahead and use the formula. Assume that a pilot sample has yield a proportion equal to 12%. So we have taken a random sample and we computed the estimation of proportion p hat equal to 12%. So this is our estimation that we can use in the formula. For 95% confidence, we used z of alpha over 2, which is z of 0.025, and that's 1.96. So we're going to use the formula. And E, the margin of error here is 3%. And P is equal to 12% because this is what we estimated from the pilot sample. So we're going to run it into the formula. Z of alpha over 2 is 1.96 here. P multiplied by 1 minus P, that's 0.12 here and here. And also we have the margin of error here, 3%. So if we plug in all this formula, we're going to get the sample size. The sample size n should be greater than 450.74. And always we have to round up. So we're going to round this up to 451. So n here should be at least 451.